Hi, in this video we're going to be looking at BuilderIO's new scraper that's called GPT Crawler. And I'm really excited about trying this because I never go into learning anything new or even working on any complex technical topic without having a custom GPT. And I find a good retrieval augmented generation, it can be better than agents with a random web search. It can help to control hallucinations because it has actual reference documentation to validate its ideas and opinions. And yeah, whenever I work on any complex topic, if I don't have a custom GPT, I usually make one. To make one, you got to be able to get high quality documents and feed it in. If you know where the highest quality documents are and you focus in on those and just those and not adding in a bunch of extra fluff, it can really significantly improve the knowledge that a bot has in being able to support you. In the past, I've written blogs about different scraping configurations I've done with some very popular scraping tools, but they're all that I've used so far were fairly complicated. I've seen some newer ones that look promising but are expensive, and this one here, even though it's called GPT Crawler, it doesn't seem to use a GPT to do the crawling. And so the action of crawling is more for the purpose of getting the knowledge to build the GPT. You don't need an OpenAI key, rack up a bill while you're crawling. So if it can do as good as it looks, I'm really hopeful that this can be the answer to simplifying the setup I've been using when I need to go scrape a page. So let's go ahead and dive in. Okay, so here we've got the web page or the GitHub page for GPT Crawler. And so you can find this at github.com/BuilderIO-GPT Crawler. And on this page, you can also see there is a link to a blog that they wrote about this product. They first released it just this past November. And the reference to GPT here is because they're using the intent for them making this, and what they've blogged about here is not using GPT for scraping, but using scraping as a way to feed a GPT. It's a great use case. I use it all the time. I think the key is now you've got so many different tools that make it so easy to do retrieval augmented generation or other types of memory subsystems like MemGPT, where if you've got a relevant set of documents that you can upload into your bot, it can empower your bot to converse intelligently about a given subject. I've used some implementations of retrieval augmented generation that are pretty basic and haven't worked well, but I feel like the bar is raising. There's a lot of communal knowledge that's emerged over the past year about how to really get the common use cases for I can upload and chat with my PDF or upload or other types of documents and have it be able to give answers with the knowledge of the additional context that you're providing it. Now, so I have a couple methods that I use to get that. Sometimes you can download PDFs. That's an easy way of getting documents. Other times you'll have Word documents, or you can upload PowerPoint files. And just about all of these solutions now, they have very robust supported base of different file types that they can support. But nothing is as universal as the web. And one of the easiest ways to have an automated job to go out and update your content is through web scraping, as opposed to some of these other means where you might manually gather files from different locations or what have you. And it's a universal, right? If I want my documentation, maybe I can get that by going and getting it through PDF if one's published. But what if I also want like the key blog articles from the top technical bloggers? Maybe there's some knowledge base. Maybe there's other types of content that's available. And I don't think there's a more universal source for content than web content. And so scraping, I think, is if you have one tool in your arsenal for gathering data, I think scraping is the most powerful one. But it's complicated, right? Well, do sites have a site index? Do they not have a site index? What's the URL of their site index? And if they do, then it gives you this nice assurance that you're finding everything, but if they don't, you have to have logic to be able to handle that. Or does the location of the site index vary on a site-by-site basis? So you have to go in and customize it. And one nice thing about LLMs is that you can feed in some junk and it'll usually sort it out. You could feed it HTML of a page and with a header and the sidebars and everything else. And a lot of times retrieval augmented generation will allow it to filter through that, but it can also create a lot of noise and distraction. I've done a lot of testing with this, and I just have found I consistently get better, cleaner results when I feed it better, cleaner data. So that's another important measure of how well our GPT crawler will do here is even if you've got a crawler, a scraper that you think can find the pages that you want to, can it get the main body of content that you want from the page and maybe ignore the rest, which is another big challenge for a lot of even the leading scrapers on the market today. You still got to go in and give it the CSS tags that are used on a particular site for where they keep the main body of content, if it's even consistent across the site. And it can be a really big challenge to identify the main bodies of text on a page. And I think some of the newer ones using GPT-4 Vision, they can do a little bit better job at that, but you're also paying a very significant premium. There's a lot of times there's individual sites with hundreds of thousands or even millions of pages, and if you're going to be gathering a good amount of data and you're paying for GPT-4 Vision for all the pages that you scrape, you're going to have an extremely steep bill for that, unless you're just trying to get a very small amount. But let's go ahead and dig in. I have never used this and haven't tested it, haven't played with it at all. This looks really straightforward. Now I've already got a container here running. This is actually one I was using for AutoGen, but it already had Node running, so I can connect it to my VS Code here, and I've already got that pulled up. You can see here on screen some of the commands I used to set up this environment. Most of them aren't relevant. The main thing that is relevant here is just installing Node. Next, we'll go ahead and clone the repo. So then we're going to say git clone. And we're going to cd into GPT crawler. As you can see here, I did this node version command. We're running 21.6.1. That meets the requirement of newer than 16. We cloned it, and then we navigated to make sure we're in the directory. So now you can see I'm in, and I can see here that I have my package.json file here that's going to have my dependencies. I need to be in this folder before I run this npmi command, because that's going to reference this package.json to determine what the dependencies it needs to install. And this is going to go make sure that everything gets installed. While we're letting that download, let's just look at this next instruction here. So it says open the config.ts and edit the URL and selector properties. Since we're in VS Code here, I can just type in code config.ts and that'll open it up here. For example here, I'm going to scrape the documents from the VMware documentation website for the Tanzu application service. So one thing I really like about this is that it has the URL and the matching pattern. I find most websites are organized in this way to where when you want to get a subset, you can use the URL to match the first part of the URL structure to say everything that matches the first part of this pattern, scrape everything underneath it. This doesn't always apply to every single website, but for me, for the vast majority of scraping that I've done, this pattern works really well, and they have it really nice and simple here. So let's go ahead and look at my VMware documentation website. So I can see here that we start with docs.vmware.com, we have our English, and then we have the name of the product, and then the version. And so I'll want to have all the files that are underneath this. Every document that starts here is what will be the documentation that I want to pick up here. If I just want to go to the main thing for Tanzu application service, that's our index.html. Okay, perfect. Now notice this is not under the 5.0, so I actually want to click on the 5.0 and see what the main page is there. And it starts with this concepts overview page. So I'm going to use this as a seed page, pick a initial URL here that is well linked. You should potentially be able to crawl to all other documents. Now that does not mean it needs to be like an index page that lists just every other document. But if you click on a link and click on another link and you go through that path, ideally you should be able to eventually get to all of the different documents within the subsection of the site that you want to scrape. We'll go ahead and paste in our filter here, our matching filter. It's going to use this match to determine whether or not it's a page that it once scraped. So we can go ahead and save this file. And we'll go back over here to our GPT Crawler site. Resize this real quick. If you see here in this example, there's a number of different pattern matching things that you can do here to further customize the scraping job. We can just go ahead and do our npm start now. So let's go ahead and see how this does. So we did our config.ts. We can't get more simple than that. I just love how simple that is. We can see it's starting to do its thing. And we ran into an error. We need to install some dependencies. So just following the instructions didn't quite cut it. But that may not be so bad, because now we can see here, and this give a really nice error message that tells us hopefully exactly what to do to fix the problem. I'll pause here while this is loading. Now let's go ahead and try it again. Oh, now it looks like we're hopefully, yes. So it is starting to do the crawl. We got our 50 pages real quick. So let's go ahead and let's look at this output1.json, because I want to see what it gathers. I do like that it has this in a nice JSON structured format. Looks like it does a really clean job of getting the text and not including a bunch of metadata. So so far so good. This looks really positive. As you can see here on each of these pages, these do match the filter. Well, this was only a brief review, and I need to get more experience with this, but I just gotta say, from my first impressions, I'm just blown away. Like every other scraping utility that I've used has been more complicated to use. Nothing I've seen that's simpler than this. You just clone the repo, install the dependencies, 2 commands, and then just tell it which site and subsite. It's very easy to use filters, and as we saw on the website, there's additional extensibility if you want to customize more about how you're filtering. It includes a nice tokenizer, the GPT-tokenizer. I looked into the code, and it's a nice NPM package that's based on OpenAI's TikTok, but adds some additional functionality onto it. And so being able to tokenize the tokenization estimates without having to call an AI model to do this scraping, it just seems at the surface to have done a really powerful, very simple, very effective job. I don't anticipate having problems with this, but as I use it more in the future, I may upload additional videos. But for my first impression, incredibly easy to use, works just wonderfully. This is going to be the scraping tool that I start with going forward, and hopefully will be the scraping tool that I just use from now on, because if every job that I approach with this is as easy as that one initially was, I'm just really excited about it. And then also how it saves the data in that JSON format is really important, because when you're scraping, you want to keep it ideally organized like that, because GPTs and LLMs haven't been known for their ability to cite documentation sources, but actually now that we're getting into more modern agent middleware, it's actually getting to be pretty good at being able to cite the resources. But it's one of the potential challenges when you're scraping data. If you just scrape it and you don't organize it well, there's no way to cite the data. So putting it in a nice JSON structure like that, where every page is still associated with its URL, will produce a data source that, if you do your agent configuration properly, will be able to cite the specific page and URL that it found the data from. And one of the really strong benefits of scraping, as opposed to getting documents from other sources, is you're able to provide a citation that someone can click on and will bring them directly to the appropriate link at the appropriate spot. It's a much more powerful citation. So another big advantage of using scraping. So I'm super excited about this. I'm going to be using this a lot going forward, and if you have questions, let me know. Put them in the feedback. I'll see what I can do. Thanks so much.